Okay. So in the last class, we basically discovered the chain rule. What was the chain rule? Let's quickly go through the chain rule once again. Let's go through it over here. So the chain rule was for bracket scenarios, and it would also be used somewhere in the future as well, right? So the chain rule was basically for such questions where, let's say, this is the first question, and it is y equals 2x plus 1 to the power 5. Now you need to find dy by dx, or you have been asked to differentiate this equation, and you can't expand it first. In cases where we had 2 here, 3 here, we were able to expand that and then differentiate it. But when you have 5 here, 4 here, or any other number here, differentiation is not that easy. That is why we use the chain rule. Now, what was the chain rule? Before writing down the chain rule, just know that whatever you have inside your brackets is basically your u, and that is it. Now we can write down the chain rule. So if I talk about the solution, dy by dx is what we need to find. Okay, so dy by dx is what we need to find. I can write it as dy by du multiplied by something that would cut du, so that would make it du by dx. Okay, now what is dy by du? Dy by du is basically differentiation of y with respect to u. So I can write the same equation in terms of u as y equals u power 5. Okay, and I know that u is equal to 2x plus 1. Okay, this is u. Okay, now dy by du is going to be, that is going to be found using this equation. So it would be, the power would come as coefficient. So 5u power whole power minus 1 multiplied by du by dx, differentiation of u with respect to x. So this is going to be, what would be the derivative of this thing? For 2x, it is going to be 2 only, right?
Yes.
And for 1, it's going to be 0. So finally, I can write it as 5 multiplied by 2, that is 10 u power 4. And I'll plug in the value of u, that is 2x plus 1 power 4. And this is going to be your final answer. Yes, Rafi and Munja. Did you find this difficult?
No, ma'am.
No, miss.
Okay, one more example. And this time around, I would not be talking about the chain rule, because obviously chain rule is part of the syllabus, but chain rule is something that is not mandatory. Like, you're not supposed to define u and do it that way. You can also do it directly. How? I'll tell you. So if I talk about another example, I can write it down this way. Y is equal to 3x minus 8 power 6. Okay, now this is another question where we have brackets. We cannot expand that. You need to do it by some other method. Some other method is, okay, so we have been asked to differentiate this. So I would write it as dy by dx. Now, how do we differentiate generally? First of all, we consider this power and we write this power before the variable, right? As the coefficient of the variable. We have 6 as the power. I am going to write 6 as the coefficient of this entire thing. So 6 would come here. The bracket part would stay as it is. The way we do it usually for variables, what happens to the power? We do whole power minus 1. And lastly, since we don't have a variable, it's something inside the brackets, you are supposed to differentiate this thing and write that as well. So what would be the derivative of 3x minus 8?
3.
It would be 3 only. Very good. So 6 multiplied by 3 is 18. And then we have 3x minus 8 power 5. And this is going to be the answer. So this way or the other, like you can use the chain rule, you can use it directly. The answer is going to be same. But I personally find this method easy because I am able to do it directly. Right, Rafi? Any confusions with this?
No, miss.
Okay, perfect. Now let's talk about some logic part. Initially, I planned on doing it in detail, but since we only have two students for now, I'm not sure about Mudison because he is taking the recordings only. So if he has some queries, he can ask me directly. But yesterday, when we were talking about past paper questions, you guys were familiar with stationary points and all that. So this is what I wanted to talk about.
Miss, for the chain rule, if like the bracket is in the denominator, so what will we do then?
Yes, very good question. Okay. Uh, so let's do one question then over here. Okay. Let's talk about example 3. And let's say this time around we have y equals 1 divided by 3x plus 5 to the power 4, for example. Okay, this is the question. Now, as I've said earlier as well, just consider this as a normal variable. Consider what is a normal variable? Consider this entire thing as a normal variable, okay? You can also do it by chain rule, but let's talk about it directly as well. Then I'll talk about the chain rule as well. So for the solution, I've been asked to differentiate. So dy by dx is basically equal to, now I know whenever I'm differentiating something, I need to have the variable in the numerator. So first of all, I need to take this thing from here to here, and it would become 3x plus 5 to the power minus 4. Okay, just think about it. In the past, when we were differentiating random variables, and whenever I had something in the denominator, I was taking that to the numerator. For example, one second. Here, we had x squared in the denominator, we had root x in the denominator, and first of all, in the first step, I've taken x squared to the numerator and I've taken root x to the numerator, right? Because otherwise I am not sure about the differentiation. So just like that, you are supposed to take your bracket to the numerator, and now the rule is same. This number right here is going to come as the coefficient, that is minus 4. The bracket part would come as it is. The power of bracket is old power minus 1. And whatever you had inside your brackets would be differentiated. So the derivative of 3x plus 5 is what, Rafe?
Miss, first, shouldn't we take like 3x plus 5 as u?
Yes, you can do that. This is what I am telling you. Now, you can also consider the chain rule and then do that. This is also the chain rule, but I have not defined u, x, y, z. I'm not doing it that way. After this, I will again do it through the chain rule method. Okay. I'm doing this question the way I did the previous one. Just look at the second question. I did not define u. I did not write dy by dx is equal to dy by du multiplied by du by dx. Okay. You can also do it directly. That's also fine. And in the previous one, I've done that to chain rule. So it is your choice, but for both the solutions, you would get same marks.
Okay, miss, got it. Miss, the
Okay.
derivative will be 3 only.
Very good. Excellent. It's 3. And this is going to be minus 12 into 3x plus 5 power minus 5. And it would give you minus 12 divided by 3x plus 5 power 5. This is going to be the answer. Now you can certainly, you could have done the same question using this is also the chain rule. The underlying logic behind the solution is certainly the chain rule, right? But I did not waste time in defining variables. But still, for the sake of completeness, let's talk about it that way as well. Or, so I would define u as 3x plus 5. So I can write it as y equals 1 divided by u power 4. And since I am not sure about the differentiation this way, so I'll take this to the numerator. And it would become y equals u power minus 4. Okay, next, how do we apply the chain rule? It's dy by dx equals dy by du multiplied by du by dx. What is dy by du? This is the equation of y in terms of u. Minus 4 would come as the coefficient. Minus 4 into u power minus 4 minus 1. And next we have du by dx. This is u in terms of x. So the derivative is 3 only. And lastly, I'm supposed to plug in the value of u. So this would become minus 12 3x plus 5 power minus 5. So this way or the other, I am getting the same answer. I can again take this thing to the denominator and this would come as positive power. Okay. So are you clear with the concept now?
Yes, ma'am.
Okay. Now we can talk about the stationary points. So in the very beginning of this chapter, I told you the application of differentiation. Differentiation is basically used to find the gradient of a curve at different points, right? We know that if we have a curve, its gradient is going to be different on different points, and this was the underlying application behind differentiation. Now imagine we have a random curve of this type. This is basically a point on the curve, and this is the tangent line. So the gradient of the red line is equal to the gradient of the curve at this point as well, right? Both the things are same. But what exactly is the stationary point? Stationary point is the point where the derivative or where the gradient of the curve is equal to 0. And when is our gradient or derivative going to be 0? That is only possible when our tangent line is horizontal. So for example, if I make a tangent line at this point, I would know that this tangent line is horizontal. The slope is 0. The gradient is 0 for the tangent line. So the derivative at this point is also going to be 0. So dy by dx is equal to 0. And what is a stationary point? Just know that this is the condition. Differentiate and equate the derivative equals 0. Again, this is another stationary point. Why? Because if I make a tangent line at this point, I know that it would be a horizontal line. The slope is 0. So again, dy by dx is equal to 0. Are we clear with the logic behind stationary points?
Yes, ma'am.
Okay. The next question basically comes about the nature of stationary points. Now, either your stationary point would be a maximum point or it would be a minimum point. So this is the maximum point and this looks like the minimum point, right? So how do we know in exam if it would be the maximum point or the minimum point? Now, I'll tell you. We know that we know this already, that in order to find the nature of stationary points, we take help of the second order derivative. Why? You will get to know that shortly. Look at this thing. If I talk about dy by dx. If I talk about first derivative, what would be the first derivative at this point? Would it be positive or negative? The tangent line is going to be something of this type. It's going upwards. So
Positive.
very good. So so dy by dx would be positive at this point. At this point, again the line is going upwards. I know whenever my line is going upwards, its gradient is positive. So dy by dx would also be positive. And at this point again, it's going to be positive. And at this point, it would be 0. Why? Because it's a horizontal line. And what about here, Rafe? Can you tell me? The line is going downwards now. So what would be? Very good. The gradient would be negative, so the derivative would also be negative. Again, at this point, if I make a tangent line, it's going to be negative, 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 0. And again, at this point, if I make a tangent line, it's going in the upward direction, upward direction, upward direction. So what have you noticed? If we talk about the maximum point, dy by dx is going from positive to negative. Okay, if I talk about dy by dx, this positive, 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 negative, 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 positive, positive, positive is basically for dy by dx. Okay, so this trend, positive, negative, and then negative, positive is coming for dy by dx. If I differentiate dy by dx, okay, now imagine that we have a graph. Okay, I'm just explaining logic for this thing. That's important for the sake of not for the sake of completeness, but just so we know things logically. If I make a graph of dy by dx, and if I start talking about the nature of points, so we are going from positive to negative. That basically means it would be, let's say it's 1 at this point, or let's do it this way. This is the positive y-axis and this is the negative y-axis. This means that I'm going from the positive y-axis to the negative y-axis. Okay, this is clear. dy by dx is positive in the first half and then it's becoming negative. Okay, so just by following this trend, I made a line that's going from positive dy by dx to negative dy by dx. And now if I try finding out the gradient of this line, what is the gradient going to be? It's going to be, huh? It's going to be what?
Going to be
Negative, right? The gradient is going to be negative. And the gradient of dy by dx is what? It is basically the second derivative, right? The gradient
yes.
of y is dy by dx. So the gradient of dy by dx is going to be the second derivative. So this is why dy by dx is when differentiated for a maximum point, the second order derivative is going to be less than 0, right? This is basically the logic. Now you need to take 2 minutes, think about the minimum point in the similar way that it's going from negative to positive, make a line on this graph and then find its gradient, just an idea about the gradient, and then tell me if you were able to understand it or not. Okay, take 2 minutes. And if you have any questions from this, just ask me right now. Yes, done.
Miss, like the graph of the dy upon dx is
Hmm.
giving us the negative gradient.
Hmm.
So, Miss, like, what does that tell us about the nature again?
Okay.
It,
Now I'll tell you. So this happened. This negative gradient is coming when we had this scenario, right? And what was this scenario? This was basically a maximum point. This happened when our dy by dx shifted from positive to negative. And whenever our dy by dx would be shifting from positive to negative, that is going to give you a maximum point. For example, if I talk about this parabola, so I know that the derivative at this point is positive, positive, positive because we are going upwards. And at this point, it would be 0 and then negative, 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 negative. Okay. So again, we are going from positive to negative. This again is a maximum point. I know that, right? So whenever dy by dx is going from positive to negative, the second derivative would basically be negative. And we know that whenever the second derivative is negative, in the background the logic is that dy by dx is going from positive to negative. And when is dy by dx going from positive to negative? Whenever you have a maximum point. Okay.
okay, Miss, got it.
So for example, if I talk about the minimum point, this is the point, and if I make a tangent at this point, it's giving me 0. So that's why it's a stationary point. Now I'm interested in finding out the logic behind the I'm trying to figure out the nature of the stationary point. So it's negative, negative, negative. What is negative, negative, negative? dy by dx, or gradient at these points would be negative, and at this point it would be 0, and at this point it would be positive. Now my dy by dx, this is for dy by dx. My dy by dx is going from negative to positive. If I think about it on graph, dy by dx, this is negative, it's going from negative to positive. So if I find the gradient of this red line, that is basically going to give me the second derivative, and I can clearly see that the gradient is going to be greater than 0, right? So this is why we know that every time when we will finding out the second order derivative, if it is positive, the point was a minimum point. If it is negative, the point was a maximum point. Okay.
Okay, Miss.
Yes. Are you both of you clear with this?
Yes, ma'am.
Yes.
Okay, perfect. Now we can talk about past papers. This was important for the sake of logic only. Okay, and on obviously in maths, logic is extremely important. Okay, so this is the first question, and this is the year. You can just note the details. Right. So, and Rafi, you can try giving the quiz now, okay? Please try doing that.
Okay, Miss.
Okay, so this is the question. Okay. Now, this question says the function f is defined by f of x equals something, something, something for x between 1 by 2 and a. It is given that f is a decreasing function. Find the maximum possible value of the constant a. Okay, now it is very, very important and very, very interesting as well at the same time. 1 second only. Right, okay. Now you have been told that this function has this interval for x, okay? So imagine I'm just giving you an underlying idea. Just look at this thing. If I talk about this parabola, what do you think? Is it increasing or decreasing? So you would say we don't know about it because from this point to this point, it is decreasing. The value is decreasing. Let's say if I make it on the graph, So according to the y-axis, if this point is 10, this point would be 1. So you would say that it is decreasing in the first half, but then it is increasing in the second half, right? But what if I talk about this part of the parabola only? So for that, I would have to define some interval, right? I would have to define some interval that x is from 2 to 4, and that is why it is increasing. Otherwise, it was also decreasing in the past, okay? This is just a random background about the question. Are we clear with this background?
Yes, miss.
That is why interval is important, okay? Acha, anyways, let's forget this. Let's do the question, okay? Now you know that the function is decreasing. So first of all, you need to figure out something out of it that would help you mathematically. If the function is decreasing, what does that imply? Can anyone tell me?
Miss, it will be having like negative gradient.
Excellent. A negative gradient is basically dy by dx. Okay, why? Because again, if I talk about a simple logical line, this is a line. I would say that the equation or the graph or the function is decreasing. Why? Because it is coming down, and coming down mathematically means that the gradient of this line is going to be negative. So always remember, whenever a function is decreasing, its gradient is going to be negative. Whenever it is increasing, its gradient is going to be positive. So this is something that you need to remember, okay? So this implies that dy, since we have f here, so I would write it down this way. F dash of x is less than 0. Now in the beginning, I told you we have several notations, depends upon the question. We have f of x here. That is why I've written f dash of x here. Okay, f is decreasing. So f dash of x is less than 0. Okay. Find the maximum possible value of the constant a. We'll talk about that first. Let's just simplify some part of the question. Now, f dash of x is what? First of all, you need to figure out that. Okay, now you've been asked to differentiate this. So how do we differentiate? This is a separate case and this is a separate case. Let's talk about the first one. First of all, I'll take this power and I am going to write this power as the coefficient. So 1 by 3 is going to come as it is. It would be multiplied by the power, that is 3 by 2. The bracket content would come as it is. The power would become 3 by 2 minus 1. And one last thing, the derivative of the bracket part. So what is the derivative of the bracket part? It is? It's 2. Very good. Then we have minus. What is the derivative of 2x? It's going to be 2. So 3 and 3 would be cancelled. And this is going to give me 1 by 2. And it is being multiplied by this 2. This is 2x minus 1 power 1 by 2. And then we have
Miss,
minus 2. Yes.
miss, where did that two come from?
Which
The one
this?
which you underlined.
This 2? Okay. This 2 is basically the gradient of this bracket part, right? We have just discussed the differentiation of brackets, the chain rule. This thing used to be u, and I've written the derivative of this bracket part over here, okay?
Okay, miss.
Very good. So upon simplification, 2 and 2 would be cancelled, and this is going to give me 2x minus 1 whole power 1 by 2 minus 2. This is f dash of x. And f dash of x is going to be what? F dash of x is going to be less than or equal to 0. Now, every time when we are writing down the condition for decreasing or increasing, you need to incorporate this less than equal to. Why? I'll tell you. Because if this is my parabola, from this point to this point, my gradient is decreasing, and at this point it is equal to 0. So overall I've considered this thing to be with negative derivative. And if I talk about the other part, I would say that the dy by dx is greater than or equal to 0. Why equal to 0? Because again this part is incorporated in the other part of the graph, right? So this is also important. F dash of x would be less than or equal to 0 for decreasing. Okay, you need to remember this. Okay, so now we know that the function is decreasing and the condition is f dash of x is less than or equal to 0. So that would imply 2x minus 1 to the power 1 by 2 minus 2 is less than or equal to 0. Now I am going to take this 2 on the other side and it would become 2x minus 1, 1 by 2 less than equal to 2. In order to get rid of this 1 by 2 or this under root, what do? We square both sides. So I am going to square both sides. And when I would square, this 2 and this 2 would get cancelled and I would get 2x minus 1 is less than equal to 4. And upon simplification, I am going to take this 1 on the other side. So this would give me 2x is less than equal to 5. So x is equal to less than equal to 2.5. What was the question? The question was about finding the maximum possible value of the constant a. Now, where is the constant a? Here is a. We know that this function is decreasing between 1 by 2 and some other number, and that other number has turned out to be 2.5. We know that whenever, not whenever, we know that for x less than equal to 2.5, this function is going to give us a negative derivative. Okay, so a is going to be 2.5 in this case. Yes, take a minute or a few seconds, try understanding the solution, and then if you have any queries, you can ask me. Yes, is it done?
No, miss, wait a second.
Okay, sorry.
Miss, how did we reach the proper conclusion that A is equal to 2.5? Like,
Okay. Yes.
not less than anything.
Yes, because of this thing given in the question. The question was that x is between 1 by 2 and a. Okay, x was between 1 by 2 and a, and we were supposed to find the maximum possible value of a. We know that for x less than equal to 2.5, our function is going to be a decreasing function. Okay, so this is your number line. This is 0. We have 2.5 here. We know that this is basically the range for f to be decreasing. Now, in the question, we have been told that x is between 1 by 2 and a only. So what is going to be the maximum possible value of a? In the question, we know that it's basically between 1 by 2 and some other value. Now I can't say that the other value is 3 because of this logic, because we got that if f has to be a decreasing function, it has to be less than or equal to 2.5, and we were supposed to write down the maximum possible value, so that is going to be 2.5. Okay,
Okay, Miss, got it.
sure.
Yes, Miss.
Okay, perfect. So it's going to be 2.5. Let's try doing the next question as well. And I could not keep that thing with me. I'll send that to you later on. The question basically is, it's a 5-mark question. It would take more time. 1 second. Let's do this one. Okay, now, yes, I have the paper code and everything for this one. Just note this.
Done.
Okay. Let's talk about this one. We'll talk about the previous one tomorrow. Now it says, the function f is defined by f of x equals x squared plus k by x plus 2 for x is greater than 0. Given that the curve with equation y equals f of x has a stationary point when x is equal to 2, find k. Now you have been told that at x equals 2, this curve has a stationary point. So things are very, very easy now. Okay. We are supposed to find dy by dx, equate that to 0, plug in x equals 2, and the only variable left in that equation would be k. So we would be able to find the value of k. Let's do that slowly. Stationary point implies that dy by dx is going to be 0. So this means that I need to find the derivative first. But again, I have f of x here. So instead of writing down dy by dx, let's just write down f dash of x equals 0. Okay, because this is the notation whenever you have a function. What is f dash of x? For f dash of x, let's rewrite f of x properly. F of x is equal to x squared plus k into x power minus 1 plus 2. I've taken this x from denominator to numerator, and this is going to be x power minus 1. And now when I will differentiate it, this 2 would come here. It would become 2x. This minus 1 would come here and it would become minus k x power minus 1 minus 1. That would make it minus 2. And the derivative of positive 2 is going to be 0. Now this thing is equal to 0. And it is 2x minus k divided by x squared equals 0. And we know that at the stationary point, x is equal to 2. So I'm supposed to plug in x equals 2. So 2 into 2 minus k divided by 2 squared equals 0. Now, as I've told you earlier as well, at this point, this equation only has k as its variable. K is the only unknown thing, and I can easily solve this how? By simplifying. So I'll take LCM at this point, and that is going to be 4. It would give me 16 minus k equals 0. This 4 would go there and vanish, and k is going to be 16. Just give me 1 minute. Let me check my answer once again. Yes, that's right. K is equal to 16. Okay. So this was easy. Whenever you come across stationary point, think about dy by dx. Nature of stationary point, second derivative, d2y by dx2. And that is it. These are the only two underlying ideas you need to remember, and you should be able to talk about past papers, okay?
Okay, miss.
Any difficulties in this question, Munja and Rafe?
No, miss.
No, ma'am. Thank you.
Okay, let me stop the recording.